Betelgeuse, situated in the Orion constellation, stands out as one of the most identifiable stars in the night sky. Its vivid crimson color and prominent placement have made it a favorite among astronomers and stargazers alike. However, it is Betelgeuse's enigmatic behavior that truly captivates. Known as a variable star, it undergoes pulsations, expanding and contracting in size over time. Consequently, its brightness fluctuates, at times making it one of the brightest stars in the sky and at others significantly dimming. With a diameter over 1,000 times that of our Sun, Betelgeuse is truly a colossal giant. If positioned at the center of our solar system, it would engulf the inner planets, including Earth, extending all the way to Jupiter. Its immense size and mass classify it as a red supergiant star, approaching the final stages of its life cycle. While the impending demise of stars is not a rarity, what has astronomers on edge is Betelgeuse's recent dimming. Between late 2019 and early 2020, it experienced an unprecedented dimming event, losing a substantial portion of its luminosity. This occurrence sparked global speculation and curiosity. Multiple theories emerged to explain Betelgeuse's dimming, but one hypothesis stood out and was subsequently confirmed by the Hubble Space Telescope. Based on the data collected by Hubble, scientists determined that the star expelled a massive cloud of dust, partially obscuring its light from our perspective. However, since the dimming event in February 2020, Betelgeuse has not repeated its cycle. What we do know is that as the star recovered from the significant expulsion of its matter, known as the Great Dimming, its surface began to fluctuate akin to gelatin on a plate. Furthermore, it has lost its natural 400-day pulsation, which had been observed for centuries. Betelgeuse continues to exhibit peculiar behavior, and while its eventual supernova explosion is inevitable due to its advanced stage in the life cycle, the exact timing remains uncertain, except for a select group of scientists. According to their research, the explosion may be happening at this very moment or in the near future. Welcome to Astro Ventures, where we embark on a cosmic exploration. If astronomers were to speculate on the next nearby star to go supernova in the Milky Way, their attention would likely turn to Betelgeuse. This bright red supergiant star marking Orion's shoulder is approaching the end of its lifespan and lies less than 1,000 light-years away from Earth. But how close is Betelgeuse to its supernova event? Will we have the opportunity to witness it? Typically, astronomers suggest that it could explode within the next 100,000 years, which is relatively soon in cosmic terms, but disappointing from a human perspective. However, our calculations may have been inaccurate, and the spectacle might unfold before our very eyes. A recent study conducted by Hideyuki Sayo and his colleagues from Tohoku University in Japan suggests that Betelgeuse might be further along in its evolutionary process and closer to its explosive fate than previously believed. The key lies in the star's pulsations. Betelgeuse exhibits regular fluctuations, with overlapping overtones, as it breathes in and out, creating its unique pattern. Over the past century, astronomers have observed changes in its brightness over periods of 2,200 days, 420 days, 230 days, and 185 days. Typically, the 420-day pulsation is regarded as the primary cycle, with the shorter periods considered as overtones. The 200-day period, often referred to as a long secondary period, is not commonly associated with the primary pulsation but is observed in 1/3 of supergiant stars. If the 420-day cycle is the primary one, Betelgeuse would span the equivalent of 800 to 900 suns lined up in a row and nearly reach the orbit of Jupiter within our solar system. However, Sayo and his colleagues propose that this estimate might be conservative. If the 200-day cycle is the primary one, with the others being overtones, Betelgeuse would be even more colossal, spanning 1,200 suns, surpassing even the width of Jupiter's orbit. Correspondingly, the star would be further along in its life cycle. Stars like Betelgeuse live fast and large, beginning by fusing hydrogen into helium within their cores, then swiftly transitioning to fusing helium into carbon. Carbon fusion gives rise to heavier elements, while lighter elements burn in shells surrounding the core, causing the star to expand outward like a hot plasma balloon. Sayo and his team employ computer simulations to track the evolution of stars from birth to old age, calculating the pulsations expected at each stage. They find that all 4 observed pulsations ranging from the 200-day cycle to the 185-day cycle can be explained by a breathing star in the advanced stages of carbon burning. The researchers note that after the carbon in the star's core is depleted, a core collapse leading to a supernova explosion is expected within a few tens of years. However, determining the exact moment when the carbon runs out is challenging as the pulsation periods exhibit minimal changes at this late stage. Sayo adds that it is currently impossible to estimate the remaining carbon in the core with precision, but they speculate that carbon exhaustion will likely occur within a few hundred years. In summary, Sayo's research group does not claim that Betelgeuse will explode tomorrow or even within the next decade. Their assertion is that Betelgeuse is more likely to go supernova within 1,000 years, rather than the previously estimated time frame of 10,000 or 100,000 years. The implications of the 200-day pulsation present challenges as well. Spectroscopic measurements indicate that the star's surface expands and contracts at a rate of approximately 1,500 kilometers per second, 3,300 miles per hour. If the star's breathing pattern occurs over the course of 2,200 days, its diameter would change by 180 times the size of the Sun during each cycle. This significant variation poses a challenge for astronomers. Additionally, the 200-day pulsation would influence the behavior of the overtones. For instance, the 400-day cycle would not consistently last 400 days. When the star expands to its maximum size, the overtone period would lengthen, while it would shorten during contraction. However, these systematic changes expected during the 200-day cycle are not clearly evident in Betelgeuse's long-term light curve, which exhibits more random fluctuations around the typical 400-day cycle. For those unfamiliar with the process, when a star exhausts its hydrogen fuel, helium begins to burn, causing the star to swell. As all fuel is consumed and the remaining elements are unable to sustain fusion, the core collapses, giving birth to a solid neutron star while the surrounding gas rebounds, triggering a supernova explosion. Betelgeuse, a red supergiant star with an estimated age of at least 8 million years, is believed to be in the final stages of its life cycle, having depleted its hydrogen fuel in the core. Will we have the opportunity to witness the explosive event of Betelgeuse? If we were to live for a couple of thousand more years, then it's possible. Imagine the extraordinary spectacle it would be, right? Share your thoughts in the comments below, and don't forget to subscribe to AstroVentures as we embark on a journey of exploration together.